In today's session, let me learn about how to reduce your state table using your transition table. Along with that, so how to minimize your state table into your minimal minimal state table using your flow tables, as well as you're using a method called as compatible pairs and maximal compatibilities, as well as your closed covering conditions. Now, so let me first derive your implication table. What does mean by implication? A table. So implication table gives you that two states which are equivalent or not. So if it is possible to have that compatibility on those two states, so which is determined using your implication table. So now it gives you the exactly the same output and go to the same next state or into the same state. So equivalent states can be combined into two states. So into one state, sorry, in the state table. And by checking your each pair of states for a possible of equivalence of table with a large number of your states can be done with the systematical by means of an implication table. So implication table is the chart of your table which consists your small squares. So one for every possibility of your pair of your states. So is it compatible? Then so it will be marked with a tick mark. If it is not compatible, then we have to mark with a cross mark. So we are going to represent each possible state compatibility with the other states which are possible in your given machine. So now here I have given one example with their state table. So with their inputs as well as your next states. So now total I have here the 7 states, so which are labeled with A to G states, and with the next state, so this is your column, these two columns are next states and these two columns are your outputs of your sequential circuit. So this example I have taken for explaining that implication table. Now with x input 0 and x input equal to 1, so we have your next state. So if your present state is A, if x input is 0, next state is D. If my present state is A, next state, if my present input is x equal to 1 is B. If my present state is A, next state is D, and the output with x equal to 0 is 0. If my present state is A with an x input equal to 1, next state is B along with the output of 0. So this gives you the state table which must be reduced. So out of the 7 states, how many possible states we can reduce, that we have to verify here using your implication table. So implication table which gives you a chart, so which will give you the compatibility of your two sets of your states or two sets of your states, so which are compatible. So then we have to mark with a tick mark. If it is not compatible, then we have to mark with a cross mark. So in order to determine that compatibility, we have to check your outputs. So now, so since if your outputs are 0 0, so here if the outputs are equal between your two states, so then it should be known as your implied states. So those two states are implicable or compatible. So then we can put that a tick mark onto that compatibility chart. So if they are not compatible, then we have to place onto that corresponding intersection square. So we have to place a cross mark here. So I almost have 7 states. So first we were going to represent all the states except your last state in a row wise, and in your column, so in your column, so we have to represent your all the states except your first state. So now upon drawing this chart, so we could have total squares, so which are implied with, for example, now A is it implied with the B state? So we are going to check all the states with all the possible states in your sequential circuit. So now we are going to compare with the remaining 6 states. So hence here we have your total 6 number of squares where it can give you the compatibility. In your B, so already we have done the compatibility on your A with the B, so hence we were moving to the C. So B to C, B to D, B to E, B to F, B to G. Next, so already we have done with the B to C, then we will move with the C to D, C E, CF, CG. Next DE, DF, DG. So like this it will be decreasing. So the compatibility squares will be decreasing when you move towards to the right word. So if they are compatible, put a tick mark. If they are not compatible, put a cross mark. So how to check that compatibility is by checking their outputs. For example, now I wanted to check whether my state A is implicable or compatible with your state B or not. So since for x0 your output is 0 and in your B also the output is 0. For x equal to 1 the output is 0 and here also the output is 0. So we will first check for your outputs, then we will move to your next state. So when I check for the next state, here A is moving towards to the D state when x is 0, when x is 1 it is moving towards the B. Where B is moving to the next state, x equal to 0 is A, B and x equal to 1 is A. So now if I wanted to check a compatibility between A and B, if these two are equal, then these D and E, if these two D and E are equal, then your A, B are equal. So hence, so we will represent that condition that state D and E, if it is compatible, then our A and B are compatible. So let me check this later. First we will put that D. Next thereafter we'll move with the C. So AC, let me check for your outputs. Outputs for C state is 0 1, for A state is 0 0. So since there is a 1 difference we have, so on your x equal to 1, so hence A is not compatible with the C. So we put the cross mark over there. Next, is it A is compatible with the D or not? Check it. So 0 0 output, here 1 0. So not compatible. Next, E is also 1 0, so not compatible. Next, we will go for the F1. F is 0 0 here. X is 0, we have output 0. X equal to 1, we have output 0 on your F2. So hence, so let me move to your states. So now, so A is D, whereas F belongs to C. Next, so A is B with X input 1, but F is going to the B. So now X equal to 1, A going, your A state F also going to the same state. So they might compatible if your CD are equal. CD are equal. Hence we put that CD, if CD are compatible, then A and F are compatible. So or A and F are so it will eventually give you the same output. So here we will put that condition. So when this will be this compatibility is checked. So whenever we are going to your checking of your C with D, so then we can know that. So is there those are compatible or not. So till that, so don't put the cross mark. Only put your CD. Next, A is compared with G. So now when I am compared with G state, so here that G state outputs are 1 0 where A state outputs are 0 0, so not compatible. Next we will move with the B. So B is compared with your C. So 0 0 here 0 1. So hence B is not compatible with C. Next B is compared with your D. So 1 0 here 0 0. So not compatible. B with E, it is also not compatible. B with F, so they are compatible if your C and E are equal along with A and B are equal. So if CE are compatible and AB are compatible. So now AB compatible is dependent on your DE. So I can't say that here. So I will write that. So if C is compatible with the A and E is compatible with the B, so then your B value is compatible with the F. B state is compatible with the F state. So hence we will write that. So don't put this cross mark. So we will check that when C is compatible with E or not. So then we will put the cross mark over here. So till that we have to put that. So C is compatible with E and A is compatible with the B. So C is compatible with A is compatible with the B. So then only this B and F are compatible. So next B with G. So B with G, 0 0 on your output of A B, but 1 0 on your output of your G. So hence not compatible. Next, C with your D E F G. So let me check. C is 0 1. So now 0 1 output is not at all there in your D E F as well as your G state. Hence all are incompatible with the C states. So hence we put the cross mark. Next let me move with the D. D value is 1 0. So may it compatible with E or not? Check with that because outputs are equal. Now we will check. So x equal to 0 same. We have your A as well as your D. So they are compatible. Obviously your so next state x equal to 0, next state with the input of x equal to 1, the next state is D. E also present state E. So x equal to 0, next state is A, x equal to 1, if my present state is E, next state is D. So here D is compatible with the E because your outputs are equal, your next state is also equal. Hence directly you put the tick mark. So now here just to see D, E are compatible, we have a tick mark. Hence here D are compatible. When D are compatible, AB are compatible. So hence we are going to put a tick mark in your first square. Next after this we will go with the D to F. D is compatible or with the F or not. So D is 1 0 where F is 0 0. So not equal. Outputs are not equal. Hence they are not compatible. So D with F is not compatible. So put a cross mark. Next D is checked with the G. So D value is 1 0. G is output is also 1 0. So now let me check for your next state. So D x equal to 0 is A next state. EG also next state is A with the x input 0. Next D is next state is x equal to 1 is D where G is going to the E. So as if D are compatible then here DG also compatible. As we have found here D is compatible, hence this state DG also compatible. Next we will compare with the E and F. E and F are not compatible because the outputs are not equal, hence not compatible. Next FG. So sorry E and G. So E is 1 0, G is 1 0. E is A next state, here also x equal to 0 A. So E with the next state x equal to input 1 input is D whereas E. So DE if the D is compatible with A, so EG are also compatible. So as D is compatible here, we have a tick mark. So we will put the tick mark here. Next, F is compatible with the G. So as F value outputs are 0, 0 and here 1, 0, so not compatible. Now, so let me write here compatible state. So now here, so AB is compatible. So we have a set AB is compatible if DE are compatible. Now in your B, so no state is compatible with this except your A. Next C is not compatible. So hence C is written as an individual state. Next D is compatible with E. So DE is compatible along with so DG is also compatible. So DG is also compatible. Next, we also have one more which is EG is compatible. EG is compatible whereas EF is not compatible. So these are the actual states which are compatible and F is an individual state. So which I have F value. So like this we will determine the primary states which are compatible and non-compatible states. So upon merging your states, so we were going to determine the states which are compatible. Here the compatible states are AB, DE, DG as well as your EG. So only we have 4 states which are compatible and C and F are not compatible. So hence here only AB, DE, DG, EG 4 states are compatible where C and F are not compatible. Now, so let me move to your compatible pairs. So now all the compatible pairs, 4 pairs we have it. So now using that 4 pairs, so we will go for your maximal compatibility check using your merger diagram. So now this merger diagram consists all the states which are assigned as your each point is assigned with the states. Now let me check here the compatibility on your. So now our primary one is AB. So hence, so see here we have here AB, C, D, E, D, G, and EG as well as your F. So based on that, so we were going to draw the lines over there AB. Next, we have here compatible states are AB, DE, EG, along with one more pair which is EG. AB, DE, DG, EG. AB, DE, EG, and DG. DG. So now, so let me draw that. So AB we have drawn here along with DE. So DE. Next EG. Next we drawn here DE. So DE, EG as well as here DG. Now it forms here a triangle shape. So which can form here three sets. So three sets of compatibility. Here two sets of compatibility. Hence here AB, DEG is one set and C and F are your other sets which are not compatible with any other state. So this is here the maximal compatible states which you obtain from your merger table. And using that merger table, so we will go for the closed covering condition. Now here we obtain four number of states which are AB, DE, DG as well along with EG are the four states. So and those four states, so using your closed covering condition, so these AB forms here two sets where DEG form an triangle with the three state compatibility. C and F are not included in your chosen set. So this is not at all closed. So hence these are the individual states. Now a set of compatibility we have to satisfy here a closed covering condition. So AB, DEG. So now either you can use A value instead of your B and instead of your DEG only one state is used. So hence I am going to use here D state along with the C state and F is your unique states which are C and F. So now so we can reduce your number of states with the that 7 states to the your 4 states. Now upon writing all the values, now let me check here. B is replaced with A and here C is written as it is, D is written as it is, E is replaced with D, F is replaced with the F. F values are also replaced as D, E, F is unique, so F is not replaced unique state and G is replaced with a D. So now all will give you the, so now verify here all the D states. So output X equal to 0 here A, here also for G also it is A. So next D, 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 1, 1, 1, 0, 0. So hence here, so these states so are replaced with unique states as A, C, D, F. So with this we can obtain your reduced state table from its implication table as well as your maximal covering diagram. So with this, so we can reduce your complexity of the designing part of your asynchronous sequential circuits.